So today I'm going to be teaching you 3 different types of alternative algorithms so that as a parent, you're more confident helping your child with their math homework, and you can also incorporate what I teach in the classroom into your home. The reason I teach my 4th graders alternative algorithms is because each one of them learns in a different way, and providing them with that variety and giving them choice is extremely beneficial to them. So our first alternative algorithm is wishful thinking. And I like to think of this as, I wish I had an easier problem. So if I was looking at 246, I wish that that was 250. So to make that happen, I have to add 4 to the top. And then in order to keep the equation equal, I have to subtract 4 from the bottom, which would give me 250 plus 116. And then add your 6 and 3. And my answer is 366. And it's really important that you explain to your child why we keep this equation equal and the difference between keeping a addition problem equal and a subtraction equation balanced. So if we had the subtraction problem, I wish that 363 was 365. And to make that happen, I have to add 2 to the top. And then with subtraction, to keep the equation balanced, I have to add 2 to the bottom as well, which is 265 and 234. 5 minus 4 is 1, 6 minus 3 is 3, and 3 minus 2 is 1. 131 is our answer. And we can check both of these with just the traditional algorithm. So 246 plus 120, 6, and 366. And then with this one, 363 minus 232, 131. So again, it's just really important that you teach your children how to keep that equation balanced so that it doesn't cause them issues down the road. And then our second alternative algorithm is partial differences, and this has a lot to do with place value. So rather than saying 286 minus 142, I can break this up and say 200 minus 100 gives me 100. And then 80 minus 40 gives me 40. And 6 minus 2 gives me 4. I add all of these up and I get 144 as my answer. A lot of children struggle with traditional algorithm because they're just looking at it at this one chunk. If you encourage your children to write it out and see all these different place values, it can be a lot easier. So if we checked this with traditional algorithm, 286 minus 142, it's kind of crooked. 6 minus 2 gives me 4, and 2 minus 1 gives me 144. And then here's another example. So 300 minus 100 gives me 200. And then 30 minus 10 gives me 20. And 2 minus 2 gives me 0. Add them all up, and I get 220. Again, we can check this with traditional algorithm. 332 minus 112 2 minus 2 is 0, 3 minus 1 is 2, 3 minus 1 is 2. 220 is my answer. Okay. And then for my third alternative algorithm, we have break up the dividend. So if I had 482 divided by 2, I can break this up into the different place values just like what I did with the partial differences. So if we broke up 482 into the hundreds, tens, and ones, I would have 400 plus 80 plus 2. So this says 482 divided by 2. How many times does 2 go into 400? 200 times. How many times does 2 go into 80? 40 times. How many times does 2 go into 2? Once. And I just add them all up. 241 is our answer. And again, just like the rest of them, we can always check these with traditional algorithm. 2 goes into 4 twice. 2 times 2 is 4. Drop down the 8. And then 4. 0. And then 0 is 1. And oops. And it checks. 241 is our answer. So these traditional algorithms can be extremely helpful for your children, especially if the traditional algorithm just doesn't work for them. It doesn't work for all students, and in my classroom I like to give choice. So these algorithms give students a lot of opportunity to show their skills without doing it the traditional way. So I hope this video helps. Thanks.